Hello students, so we are going to continue with exercise 1.3. We have already learned how to prove root 2, root 3 as irrational numbers, and I said that it is very important from exam point of view as it will come for 4 marks. Okay, so like a theorem we need to write each and every step. Now today we are going to learn that if the same type of questions comes not in the form of root 2, if it comes for 3 marks and 2 marks, like for example, prove that 1 upon root 3 is an irrational number, prove that 7 root 5 is an irrational number, and 5 minus 4 root 2 is an irrational number if I have to prove, and it comes for only for 3 marks or 2 marks, should we write the same step and how are we going to proceed? Okay, so now listen very carefully. Only in the exam, if it comes in the form of prove that root 2 is an irrational number and it will come for 4 marks, then only if it comes for 4 marks, listen carefully, 4 marks, then only you have to solve the whole theorem, the whole blah you remember. We have taken a upon b is a co-prime integers, squaring on both the sides. We can we prove that no, it is not, it has a common factor and we proved it, right? So if it comes for 4 marks, you will write the whole theorem. So if it comes for 3 or 2 marks, you have to remember a very important fact that for 3 and 2 marks, we know the fact that root 2 or root p, root 3, root 5 or root p is an irrational number. This fact we know. We know this fact and we prove, because see here it is 1 upon root 3 we have to prove it's a rational number. 7 root 5 is a rational number. So in this cases we know that root 5 is a rational number. Here in this case we know that root 3 is a rational number. We don't know about 1 upon root 3. We know that root 3 is a rational number. We know root 5 is a rational number. We know that root 2 is a rational number. This fact we know. This thing we have to assume that we know this fact and then we'll prove the whole sum to be an irrational number. I hope I am very clear. Okay, so again a quick recap. If it comes for the here's a form of a theorem, for 4 marks you have to write the whole blah which I have already explained you. If it comes for 3 marks and 2 marks, you have to accept the fact, or you know the fact. Okay, we have to assume the fact that we already know that root 2, root 3, root 5 or root p is an irrational number. We know the fact and then we prove for this. Okay, let's come into this example. First we understand. Okay, now here we prove that 1 upon root 3 is an irrational number. Now this is for 3 marks, we'll assume. 3 or 2 marks you write the same step. Okay, it doesn't make a difference. For 3 or 2 marks you write this following steps what I'm showing you. So if I want to prove that 1 upon root 3 is a rational number, I said that we already know that root 3 is a rational number. Okay, we are following the theorem starting steps and then we will proceed. Now here we will write the same thing. Contradiction method only we are going to do. So contradiction method will assume, let us assume that 1 upon root 3 is a rational number. Let us assume that 1 upon root 3 is a rational number. So if you assume that 1 upon root 3 is a rational number, that means we will write therefore 1 upon root 3 equal to a upon b. Very important condition of a and b. A and b are co-prime integers and b not equal to 0. I already explained co-prime integers means the integers they don't have any common factor other than 1. So here we will write the blah that a and b are co-prime integers and b not equal to 0. Right? So now I know the fact that root 3 is an irrational number. We know this fact, we know. Okay? So if we know, so here we will just take the reciprocal, or we can cross multiply anyhow. So if I take the reciprocal on both the sides, taking reciprocal on both the sides, so what we get if I take reciprocal on both the sides? Here we will get root 3 equal to b upon a. Now just see, I get root 3 equal to b upon a. Here I know that, coming to RHS, please see the RHS. Here we know that root 3 is a rational number. What about RHS? We know that b is integer, a is integer, and a quotient. Quotient what we get by dividing an integer upon an integer is nothing but a rational number. So b upon a is a rational number. Now when this equal to sign in mathematical, we know that if this is rational, obviously this also should be rational. Correct? Why we write an equal to sign? Because if this is rational, this is also rational. But this contradicts the fact that root 3 is irrational. Therefore, 1 upon root 3 is irrational. So, I will just say you this. So, what here for 3 and 2 marks, since we know the fact, what we have to do is, we have to take the root number, whichever the root p, I'm saying in short in root p, we have to bring it on one side, either on LHS or RHS, you see that it is positive. So we bring on one side, take all the numbers to the other side. Take all the numbers to the other side and then we give an argument that this is rational. If this is rational, that is RHS, LHS is rational. So root also should be rational. But that is contradicting the fact because that is irrational. And therefore we assume that our assumption is wrong. Correct. So here what we did, again the same thing. I have taken the root on one side and took the other numbers on the other side. So we got here b upon e. So we know that root 3 is irrational. We don't know about 1 upon root 3. Correct. So here root 3 I have taken on one side by taking reciprocal. Even if a cross multiply, what will I get? I'll get root 3a equal to b. Correct. Therefore root 3 equal to b upon a. Doesn't make any difference. So both are same. So here we will write an argument that b, since b and a are integers, they are integers, therefore I can say b upon a is a rational. Do you all agree? When you divide a integer by integer, so you get as a rational number. So b upon a is a rational number. Correct? So b upon a is a rational number, therefore root 3 is also rational number. So if root 3 is rational number, but this contradicts the fact that root 3 is an irrational number. Root 3 is an irrational number. Therefore, our assumption is wrong. Therefore, 1 upon root 3 is irrational number. Correct? Moving to the second sum, again we will assume the contradiction method. So how will we say? Let us assume that 7 root 5 is a rational number. Therefore 7 root 5 equal to a upon b, where a and b are co-prime integers and q not equal to 0 we will assume. Then we will see that root 5 will keep on one side and take the 7 to the other side. And again we will follow the same argument. Let's see. So here I will not write the whole step, but you understand. Let us assume that 7 root 5 is a rational number. So therefore 7 root 5 will be equal to a upon b. Again here where a and b are co-prime integers. Again they don't have any common factor. So a and b are co-prime integers and b not equal to 0. Correct? And then here I will just see that this root 5 is 7 into root 5. Root 5 is on one side. I'll take the 7 on the side. So here 7 goes. So it will come in the denominator, that is 7b. Correct? So now so simple. So now you will say, since a and b are integers, therefore a upon 7b is rational number. So it is a rational number. So if this is rational, a upon 7b is rational, this implies that root 5 is also a rational number. Root 5 is also a rational number. But this contradicts the fact, as I said, for 2 and 3 marks, we know the fact that root of p being a prime number, it is root of prime number is always an irrational number. We accept this fact for 2 and 3 marks. Okay. So here root 5 is a rational number. This implies, but this contradicts the fact, that root 5 is an irrational number. So here we see this argument. Therefore, our assumption is wrong. And therefore 7 root 5 is an irrational number. I hope you have understood that if a question comes for 2 or 3 marks, how you have to solve. Coming to the next sum, moving to the next sum. So I have shown multiplication, here division type of sum, how you have to do. Right? If you have any other number the same way, your aim is that you have to take on one side and bring the numbers to the next side. Okay. Now so 5 minus 4 root 2 is an irrational number. So again, contradiction method, let us assume that 5 minus 4 root 2 is a rational number. Correct? So if I say it is a rational number, again we will say therefore 5 minus 4 root 2 equal to a upon b. where A and B, very important, huh? Please always write A and B are co-prime integers and B not equal to 0. Correct? B not equal to 0. So again I said here, we will keep root 2. We will see that root 2 is on one side and bring all the rest of the numbers to the RHS. Now in this case, I will now take to RHS because here I find that it's a negative sign. So I will take the root sign to RHS to make it positive and bring the rest of the number this side. Suppose it was plus. Suppose it was 5 plus 4 root 2. Then you will keep root sign here and take 5 this side. Suppose it was 5 plus 4 root 2 equal to A upon B. Okay, so what would I do? I will take this plus 5 this side. So I get 4 root 2 equal to A upon B minus 5. And then I take LCM, then I take 4 on this side. So the root 2 is on LHS, right? But in this case, since here our root sign is negative, so I will take minus 4 root 2 on that side, so that becomes positive. So what will I get? I'll bring A upon B on this side. So I'll get 5 minus A upon B, and 4 root 2 I'll take this side, so I'll get this. Correct? Let me take LCM first. So I'll get 5B minus A upon B equal to 4 root 2. Correct? Now I want only root sign here, so I'll keep root. It is 4 into, so into will come here. It will become divide. So I'll get 5B minus A upon 4B. Do you all agree? So here, this root here, I have seen that root remains in RHS. All the numbers I have taken here. Now, how will you argue? You will give the same argument step that B and A are integers. Since B and A are integers, A, B and A are integers, therefore 5B minus A is rational number, is integer. So 5B minus A is also integer, therefore 5B minus A upon 4B is a rational number. So if this is rational number, this implies root 2 is also rational number. Correct? Because if LHS is rational, therefore if RHS is rational, if this is rational, so this also has to be rational. Therefore root 2 is also rational number. The next step, but this contradicts the fact that root 2 is an irrational number. The fact that root 2 is a irrational number. Root 2 is an irrational number. Therefore, our assumption is wrong. Therefore, 5 minus 4 root 2 is an irrational number. So, I think in this particular video, you have understood that if it comes for 2 or 3 marks, we don't have to write the whole blah blah like a theorem. We just have to keep in the mind that we know that root of any prime number, it's a irrational number. So in this case, we know that root 3 is a rational number. In this case, we know that root 5 is a rational number. And in this case, we know that root 2 is an irrational number. Also, I will just go. You also can have this kind of sum in the board exam. Like for example, prove root 3 is an irrational number. Root 3 is an irrational number. And hence prove suppose this one I take, hence prove that 5 minus 4 root 2 5 minus root 3 is an irrational number. I have this taken because here I have taken. Okay. So suppose for example this question comes this way. Prove root 3 is an irrational number and hence prove 5 minus root 3 is an irrational number, and this is for 4 marks. This is for 4 marks. Now in this case what you will do? Will you prove that root 3 is a rational number, the whole theorem, and then again for 3 marks will you prove? No. In this case I will suggest you, if this kind of questions come for 4 marks, here, so the bifurcation will be for this much to prove the theorem, this will be for 3 marks. And to prove this will be only for 1 marks. Okay, so how we are supposed to write? So here if we have root 3 is an irrational number, you will prove the theorem same way. The big blah blah, you will write the whole theorem. When you come to this step, then here we have proved that root 3 is a rational number aside from the theorem. Here you will write, we will write the property which you have already learned in standard 9. What is the property we have learned? That the difference of a rational and an irrational number is also an irrational number. We know that difference of a rational and an irrational number is also an irrational number. We have also a quick recap. Sum of a rational and an irrational is also an irrational number. So once we have proved that, then you will write that 5 minus root 3 is also an irrational number by giving the property that difference of a rational and irrational number is also an irrational number. You all agree? Difference of a rational and an irrational number is also an irrational number. For example, okay, suppose the question comes this way. Prove that 7 root 3 is an irrational number. Then what will you write? Here you will write, here especially it is a product. So you will write here product of a rational. No, you will write product of a non-zero rational. Product of a non-zero rational. Why this word is very important, non-zero? Because if it is 0, because rational number 0 is also rational number, right? So if you write 0 into anything, then again it will become 0, right? So here product of a non-zero rational number, and 0 is rational number, right? So product of a non-zero rational and a irrational number is also an irrational number. So when you write, when the product or quotient, the rule is same, because if you have 0 into any number, you will get 0, which is a rational number. So you have to be very careful. So if the product is there, the word product or quotient, if you have upon something you have to prove for 1 mark, so directly you can write 7 root 3 is an irrational number, because reason product of a non-zero rational and an irrational number is also a irrational number. Correct? So once you understand, so if this is for 4 marks, this is for 3 and this is for 1 mark, so total 4 marks. So actually students get confused in this and they write very long step, which is not necessary. So I hope it is very clear how to write this step. This particular exercise is very important. Every time either question from 2 marks, 3 marks or 4 marks, any one type it occurs in the board exam. So I hope it is very clear how you to write. Okay. Bye. Thank you. Try out the remaining sums of the textual, which is for you, because I have done every type of sum here. Okay. Bye. Thank you.